suppose that you had this problem to integrate. Easy, right? Because what do you get for antiderivative?
Like natural log of x plus 1.
Yeah, ln of x plus 1 plus
Plus 2 ln of x plus 2.
minus 2.
Yeah, oh, minus 2. Oh.
You can almost like write the answer down, everybody, right? Plus your favorite constant. And what about this one? Anybody have any ideas?
Split the denominator into like in the split it, yeah, factor it out.
Split the denominator.
Oh, factor it out.
Is that the only way?
No. Resubstitution.
Are you talking about rational function decomposition? Anybody seen that technique before or know about it from before? I guess you know about it from before,
I
yeah?
don't know the terminology, but yeah, I'm not sure. Sure we will.
Well, I guess what happened, you guys, in the back there paying attention, it's surfing the web. I know. I don't even have to be right there. I could see a reflection in your glasses on the screen. I'm telling you. Okay. All right. So probably somebody sat around and said, okay, gee, I don't know exactly how to do this. I could think of, a way. What's suggestive is that there's x dx and there's a 2x squared. So if I did a u substitution, I let u equal x squared minus x minus 2. My du is almost okay. The problem is this extra 1 right here. Otherwise I'd have a du in the numerator. Not insurmountable. I could do it. And then what I would have to do is convert the this integral into two integrals. I'll do that in a minute, I guess. It's not really the clean way to do it. Let me just show you why, actually. So I got a u there, right? And here all I got is x dx. So what I could do, the 2 is not a problem because I could just divide by 2 here. So I have du over 2 equals x minus 1/2 times dx. Of course. So I could play a little trick right here. I could say, all right, instead of x, just add and subtract 1/2. I'm not doing anything there, right? And then x minus 1/2, I'll take that. And then I have plus one half. So now I'll have two integrals. There's my du u, right? Correct? But then I also have, and where u is equal to that. But then I also have the plus 1/2. Bless you. Plus 1/2 of the integral dx over the same quantity. You missed the quiz.
Huh? No.
Confidence. Do you guys see what I mean? It's not, I can proceed, because that's just ln of u. And then the way I would do that is I would factor it. I guess. No, sorry. I would complete the square
No worries.
here. Let me back up. Here I could complete the square and then see whether I use what kind of trigonometric substitution. It's doable. But nobody noticed that actually, I guess, that what I wrote down originally here is actually this quantity. I think that's how people got clued on to the technique of decomposition by a rational function. By looking at one that was, boy, what am I gonna do here? What did I put minus one, right? X squared minus two x. Minus two. That looks, not straightforward. Like, okay, let me try and factor that. And they factor that and notice that's x plus 1 times x minus 2. So then they ask the question, can I write this way? If I could just find constants A, B, and B, A and B, excuse me. Yes, you can. If you can find those constants, you're done. Because that's just A times ln of x plus 1 plus B times ln of x minus 2. And we could look with hindsight that A is going to turn out to be 1 and B will turn out to be 2. Do you guys see that? First of all, yes or no? I mean, if that looks a lot like that, where A is 1 and B is 2, and you can see that the end result as well. So that's how the technique, I believe, developed, just by necessity to find the antiderivative or something like that. Questions? I remember when I was taking exams, if I ran out of time and I had to do an integral like that, I would just do the integration with the a's. In other words, I'd just to get points, I'd go, let me go up here. I'd look at that as a times dx. Because I know there's a constant, and I just need time to find it. And then there you go. I get the same, I get the form of the answer immediately, right? So it's going to be A ln of x plus 1 plus B ln of x minus 2 plus C. I did all the calculus there. I just didn't do the algebra. Only A and B. Okay. So that's the mindset in this section, is to take your rational expression, it's called integration of rational functions by partial rational function, integration by partial fraction decomposition. That's